So in this video we're looking at paper 2 for the Higher 2025 maths paper. So in this first question we have triangle ABC and we've been told its vertices are A, which is minus 9 minus 14, B, which is 9 20, and C, which is 21 minus 24. And the first thing it wants us to do is find the equation of the altitude through B. So there's two key bits of information there. It's the fact that it's the line going through B, so it's going to have to be this one here, and we also have to think about what altitude means. So altitude, I'll write this up here, means that we meet at 90 degrees. So we meet at a little right angle, so I'm just going to do that little symbol there. So because we're thinking about this one here, I'm just going to highlight in this colour. It's that line there because we know it has to go through B, and we've also been told it's the altitude. So that tells us that we are meeting this line here at a right angle. Not the best because it's in red, but we are meeting it here at this right angle. So we have to think of two things here. Keep in mind that the altitude is just a straight line. So you want to think about your equation of the straight line throughout this whole question actually. So we have for straight lines that y equals mx plus c. But if we don't have the y-intercept, then we're going to have to use y minus b equals m on x minus a, and then do a bit of rearranging. So the two things that you need to have the equation of the straight line are a point on the line, so you can have like your a and your b to sub in, and then you also need to know the gradient as well. So keep that in mind whenever you're doing this sort of question. Do you have a point? Can you find the gradient? And that's generally enough to kind of plot through. So for part A, we have said that we've got the altitude, so we're meeting at 90 degrees, and so that's going to help us find the gradient for that line. We already know we're going through point B, so we've already got the point 9 20, so we're halfway there, we just need that gradient. And the thing that you want to remember is that for perpendicular lines, so that just means two lines that meet at 90 degrees, m times m perp has to equal minus 1. So what that tells us is if we can find the gradient of the line AC, we can then flip it and change the sign to get the gradient of our altitude. Because whenever we have these two lines meeting at 90 degrees, say for instance AC ends up having the gradient of minus 1, then that tells us that the line for the altitude is going to be 1. Or say for example the line AC has a gradient of minus 2, then that tells you that our line for the altitude is going to have the equation of the gradient of a half. That'll make more sense as we go through. So for this one here, the first thing we're wanting to do really is to find out what is the gradient of AC, and that'll help us out. So we've got 2 points on this line, so straight away you want to think about y2 minus y1 over x2 minus x1. And you just want to sub them in. It doesn't matter which order you get as long as you kind of keep your points together. So if we do y2 minus y1, I'll have minus 24 minus minus 14. Don't forget some brackets here. And then we also have 21 minus minus 9. So minus 24 minus minus 14 is the same as minus 24 plus 14. So that's going to give us minus 10. And then 21 plus 9 is going to give us 30. And so this actually gives us minus a third. So we know that our line AC has the gradient of minus a third. And then we can use that property in blue to say, therefore, the gradient of our altitude, which I'm just going to call alt, is equal to 3, because you want to change the sign and then flip it. So you want to flip your kind of 1 and 3 around, and that would give you 3 over 1, which is just 3. So that's why we can say it's just 3. Grand. Okay, so now we've got the gradient, we can just sub that into our equation of the straight line, also alongside our point 9 20. So that tells us we've got y minus 20, and that is equal to 3 on x minus 9. We then want to do a little bit of rearranging, and then we can neaten it up a little bit as well. So we can have y minus 20 equals 3x minus 27. That then gives us y equals 3x, and if we add 20 to both sides, we're just going to have minus 7. So our final answer is y equals 3x minus 7 for part A. So you're getting 3 marks there. So you're going to get a mark for finding the gradient of AC, a mark for getting the gradient of the altitude, and then a mark for getting your final equation as well. Okay, so for part B, we want to find the median through A, so the equation of the median through A. So we have to think about a a couple of things here. The fact that we're going through A, and then also the fact that it's the median. So you want to think about what the median means. So the median tells us that it meets at the midway point. So median kind of means middle. So it's going to go through a midpoint. You just want to make sure that you're thinking about the midpoint of the correct line. So we've been told that it goes through A, so it's definitely going to have to be this line here. And then the fact that it's the median means that it's going to be going through this midpoint here. And so we have that these two segments are equal because it's splitting it perfectly in half. So that tells us that we're going to have to find the midpoint of BC, and that'll tell us what this point here is. And if we know that point there, then it means not only do we have another point on the line, but alongside A, we'll be able to find out what the gradient is using y2 minus y1 over x2 minus x1. Because again, we've just got a straight line here, and we're aiming to say the equation of a straight line. So for that, we need to know a point on the line and the gradient. We already have the point A, so to find the gradient, we need to use the fact that the median goes through the midpoint, and then that will give us those 2 points that we can use to find our gradient. Grand. Okay, so we want to figure out what the midpoint of BC is, and there's a couple of ways you can do that. You can either use our midpoint formula, or you can kind of do it by inspection. So the way to do it by inspection, which can sometimes be a little bit quicker, just depending on the numbers, is you want to think about the difference in x and the difference in y, and then just find the halfway point. So between B and C, in the x coordinates, we're going from 9 up to 21. So you want to think, what's the difference between 9 and 21? And you'll end up getting 12, just because 21 minus 9 is 12. So that's the total difference. That's how kind of long that line is in your x coordinate. That's your change in x. Because we want to think about just halfway rather than the full way, it means that we're just going to either do 9 plus 6 or 21 minus 6, just because 6 is half of 12. And so if you've done that, that would tell you that this midpoint that I'm just going to call capital M is going to be 9 plus 6, so that gives us 15. We can do the same with the y's, so you want to think about what's the difference between 20 and minus 24. So 20 to 0 is 20, and then further down to minus 24 is another 24. So that's actually a difference of 44 there, because it's your 20 plus your 24. So if the full distance is 44, half of the difference is going to be 22, because we're just halving it. So what you can do is either 20 minus 22, or you can do minus 24 plus 22. Either way, that's going to give you minus 2 if you do that. So that tells you by inspection that your midpoint has to be 15 minus 2. If you want to use your equation instead though, what you can do is say that this midpoint M, I'll just draw up here, is just going to be the average of the two. So you're going to do in your x's, it's going to be 9 plus 21, and you divide that by 2, or and then for your y, you're doing 20 plus minus 24, which is just minus 24 over 2. And then that is going to be the same as, so 9 plus 21 is 30, so you've got 30 over 2, which is 15, and then 20 minus 24, that's going to be minus 4, minus 4 divided by 2 is minus 2. So either way, you're going to get that 15 minus 2 popping out. Grand, so now we know what that point is, we just have to find the gradient. And generally speaking as well, because when you are doing the equation of the straight line, you're going to have to sub in a point on the line, I would always pick the point that we know for sure, because say for example you made a little mistake and 15 minus 2 wasn't correct. If you use the point M to sub in to y minus b equals m on x minus 8, then you're going to make a little mistake and you're not going to get your final mark for the correct full answer. But what you're best doing is subbing in the a that we know about. We know the coordinates of a for sure, they've been given in the question. So when it comes to subbing in, you want to sub in for point A. Let's find the gradient first though. So we're going to use the point minus 9 minus 14 and 15 minus 2. So if we do that, let me just scroll down. So for part B, we're going to have to find our gradient of our median through A, and we're going to use y2 minus y1 over x2 minus x1. And then we have said that our A is the point, I'll just pull it down. So we've got minus 9 minus 14. And then we've said that our midpoint is the point 15 minus 2. So we've got them there, just so we can see them. So if we do y2 minus y1, then you can get minus 2 minus minus 14 over 15 minus minus 9. and then minus 2 plus 14 is going to give you 12, and then 15 plus 9 is going to give you 24. We can then divide the top and the bottom by 12, and that is going to give you a half. So we know the gradient of our median there is a half, and you can just double check that you think that's roughly right as well. We can see it's positive, so we're happy that it's a positive gradient, and then it's not super steep. So based on the fact that we got 3 for our gradient of our altitude, it makes sense that this is roughly about a half. So you kind of want to do a little bit of a logic check as well. Grand, okay, happy with that. So our next thing to do is just to use our equation of the straight line with m equaling a half, and then we're going to want to use that point A rather than point M, just because we know A for sure. So we're going to have y plus 14, because it's minus b, but our b is minus 14, so you have that double negative there. Our m is a half, and then we have x minus minus 9, which is x plus 9. Grand, we can make that look a little bit nicer. If you want to get rid of the half as well, you can just times everything by 2. It's completely up to yourself, or you can just keep the half there, but you are going to have to do a little bit of fractions at the end. What I'll do is I'll times everything by 2, so that I've got 2y plus 28 equals x plus 9, just to get rid of that half. And then I will move my x over, and I'll move my 9 over as well. So you can have 2y minus x, and then 28 minus 9 is going to be 19. And that is equal to 0. Or if you wanted to write it in the other format, you could say that so you can rearrange as normal, and you would have that 2y equals x minus 19, because you're going to have 9 minus 28, and then you can divide everything by 2 again if you wanted. So you'd have a half x, and you'd have minus 19 over 2 there. So it doesn't matter which way you write it, as long as you're getting the right numbers, then you're generally good to go. They're just equivalents of one another, so they've just been rearranged slightly differently. Generally speaking though, if you've got a fraction for your gradient, it's quite nice just to kind of times everything by that denominator to get rid of your fraction, and then you can rearrange as desired. Okay, for part C, we want to determine the point of intersection of the altitude and the median. So we're literally just wanting to take our two equations from A and B, and because we're wanting to find the point of intersection, we can just set them equal to one another. So I'll make some room here. Okay, so because we want to set these equal to each other to find our point of intersection, it means that we definitely want both of them in the form y equals. So if you have multiplied by 2 to get your final answer looking like this, then you're going to want to do some rearranging so that you can make it look like that. Otherwise, you're not going to be able to set them just equal to each other straight away. You have to have them both in the form y equals to do that. Okay, so keep in mind that we're saying it's the point of intersection, and so we're looking for this point here where these two lines are crossing over. So whenever two things intersect, they're equal at that point. So that's why we're going to set them equal to one another. So we're going to use our y equals 3x minus 7 and our y equals a half x minus 19 over 2. So not necessarily the nicest numbers, but that's okay, we can still plot through it here. So what I'm going to do is just rewrite I'll just highlight them so we can see what we're looking at. So what we've got here is our equation from A and our equation from part B, and we're setting these equal to one another. So because both of these equal y, and because we know that at points of intersection our two things are equal to one another, then we can just set 3x minus 7 equal to a half x minus 19 over 2. So if we do that now down here for part C, 3x minus 7 equals a half x minus 19 over 2. Then what we can do is move some x's over, so we're going to move our half x over to the other side by subtracting a half, and then I'm also going to add 7 to both sides, so I have all my x's on one side and all my numbers on the other. So I'll just write it step by step for now. So 3x minus a half x, and that is going to be equal to, so I'm going to move the positive 7 over, so it's positive 7 minus 19 over 2. You could also have minus 19 over 2 plus 7, it really doesn't matter. Grand. Okay, at this point it is on a calculator paper, so if you wanted to do 3 minus a half in your calculator, then by all means, and you get 5 over 2. If you didn't have a calculator, I hope you do in your calculator paper, but say this came up in a non-calc paper, then you would want to change your 3 to be in terms of halves, so it's going to be 6 halves, since 6 divided by 2 is 3. So you could do it that way, so you'd have 6 over 2 minus a half, and then that would give you 5 over 2. But you can just use your calculator and we get 5 over 2x, and that is equal to, so if you then do 7 minus 19 over 2, that is going to give you minus 5 over 2. And so what you can actually do is just divide both sides by 5 over 2, but they kind of just cancel each other out. If you're dividing both sides by 5 over 2, you're just going to get x here, and then you're going to get minus 1 here. Grand. Okay. Your last step, because we wanted the points of intersection, you need your x and you need your y. We've currently just got an x coordinate, so we also want our y coordinate, and you can sub it into any of the two equations for y. You'll get the same number popping out either way. I would just pick the top one here because I've not got any fractions and it makes my life a little bit easier. So we have got y equals 3x minus 7. When x equals minus 1, we're going to have 3 on minus 1 minus 7. So that gives me minus 3 minus 7, which is minus 10. And so our point of intersection is going to be minus 1 minus 10. Grand. Running out of room there, so it's a little bit messy, but hopefully that makes sense. So generally speaking, for points of intersection, you want to set the two equations equal to each other when they're both in the form y equals. If they're not in that form, you have to rearrange so that you've got it in that form. After that, you want to solve for x just by doing a little bit of rearranging. And then once you find your x, don't forget to go back and find your y just by subbing in that value of x into one of your equations. You can pick either one, just pick the one that's going to make your life a little bit easier. So I personally like to avoid fractions. Grand. Okay. So for question 2, we want to express 2x squared plus 16x plus 5 in the form p on x plus q all squared plus r. So this is a completing the square question. This is very similar to the completing the square questions that you get in National 5. You just have this additional step because we've got a coefficient of 2 and we don't want a coefficient over x squared. So the first thing we have to do is take 2 out as a common factor, and we're going to take it out as a common factor just from our first two terms. You don't want to take it out as a common factor of your plus 5 at the end, because 5 isn't nicely divisible by 2, and it just makes our lives a little bit easier. So what we can do is use some big square brackets, and that's going to leave us with x squared plus 8x, just by dividing the first two terms by 2. And then we still have our plus 5 on the outside that we kind of ignore until the very end. Okay, now what we want to do is doing our completing the square as normal with the things that are inside our square bracket. So we want to do just normal completing the square with your x squared plus 8x. So I'm going to keep my 2 and I'm going to keep my big brackets. And then what we normally do is write our bracket with your x and you keep that sign the same. So we're going to have x plus, and then we want to half the coefficient of x. So because we've got an 8x here, we're going to half it to get 4, and then we close that and put a square there. Your next step is to subtract this number squared. So 4 squared is 16, so we're going to have minus 16, and then I'm just going to close that square bracket and keep my plus 5 there. So a little reminder, what you want to do is just kind of take out that common factor from your first two terms, and then we're doing completing the square with what is inside your square bracket. And what we generally do is you have your bracket with your x and then plus or minus half of the coefficient of your x term. So because we had plus 8x, we end up getting a positive 4. We then close that bracket and square it, and then you have to remember to subtract that number squared. So 4 squared is 16, so we have to subtract 16, and that's just kind of correcting our bracket there. But that is your general steps from Nat 5. The only difference is we've got this 2 on the outside, we've got these square brackets, and we're just pulling that plus 5 down the whole time. At this point, we want to get rid of those square brackets just by multiplying everything through by that 2. So we're going to have 2 on our bracket x plus 4 all squared, and then we also have 2 times minus 16. So don't forget to do that as well. That gives us minus 32, and then we still have that plus 5 at the end. It's now at this point that we can pull that minus 32 and that plus 5 together. So we have 2 on x plus 4 all squared, and then minus 32 plus 5 is going to give us minus 27. And that is you. So that's you getting 3 marks from that. So you just keep in mind to take out that common factor, do the completing the square as normal, and don't forget that plus 5 at the end. And then when you're multiplying your square bracket out again, make sure to also times that minus 16 by 2 as well. So for question 3, we have the diagram showing the graph of y equals x squared minus 2x plus 3. So that is our curve here. And we can see that. And then we're also got the shaded region between 2 and 4 as well. So I'll scroll down and we're wanting to calculate the shaded area. So keep in mind that the area under the graph is what we get when we integrate and when we sub in those limits. We have these upper and lower limits here. So what this is asking us to do to find the area is to integrate our function. So we've got x squared minus 2x plus 3. And we have these limits because we don't want the full area under the graph. We just want this shaded area under the graph, which is between x equaling 4 and x equaling 2. So all we have to remember is to have our upper and lower limits as well. And we're just integrating with respect to x. Okay, so our next step is to integrate as normal, term by term, and then we want to keep those upper and lower limits as well. Keep in mind, when we've got upper and lower limits, we don't have a plus c anymore, because we don't need a constant of integration, because we can actually just solve with these limits. So if we integrate x squared, we're going to get x cubed over 3. And then with minus 2x, that's going to become minus 2x squared over 2. So that's just going to become minus x squared, since we've got a 2 over 2 there. And then we're going to have a plus 3x at the end. And then this is with 4 and 2 as your limits. So don't forget that we have to pop them in square brackets. And then we want to sub them in now, doing upper minus lower. So what we're going to have is our 4 cubed over 3 minus 4 squared plus 3 times 4. And then we subtract it all with 2 subbed in. So you want big brackets here. So we're going to have 2 cubed over 3 minus 2 squared plus 3 times 2. Grand. Okay, so for this you want to be using your calculator. So for 4 cubed divided by 3 is going to give us 64 over 3. You can, if you want, pop it on your calculator now. Just be careful not to make any mistakes. I'll just do it a little bit more and then you can pop it on your calculator. So 4 squared is 16. And then 3 times 4 is 12. And then I'm going to keep that minus there for now. 2 cubed is 8, so that's going to give us 8 over 3 minus 4 plus 6. Grand. Okay, at this point I'd probably just pop that into your calculator. And then once you do that, you end up getting 38 over 3. And because we're talking about area here, we normally just write units squared as well, because we don't actually have units given in the question, so we just write units squared. So the biggest thing for this is to remember that you're integrating just term by term, and then you want to do upper minus lower when you're subbing in those limits. Don't forget, if you're popping this in your calculator, to put brackets around these terms here, because we're subtracting all of that. So don't just do the minus 8 over 3, you also have to do minus 4 and then minus 6 as well. So yeah, keep your brackets in your calculator and then you should get the correct answer popping out at the end. So on to question 4. We have a function g defined by g of x equals x minus 4 all cubed, where x is in a set of real numbers, and we want to find the inverse function, g inverse of x. So there's a couple of different steps to follow when you're finding the inverse function. What you generally want to start with is just rewriting this with y equals. So rather than g of x, I'm just going to write y. So y equals x minus 4 all cubed. And then what you want to do is just literally swap y and x around. So I'm going to write x equals y minus 4 all cubed. What we want to do now is make y our subject. So we're going to do a little bit of rearranging so I can write this as y equals again. So what I'm going to have to do is take the cubed root of both sides to get rid of that cube. So I'm going to have the cubed root of x is equal to y minus 4. And then I'm going to add 4 to both sides. So I'm going to get y equals the cubed root of x plus 4. So I've just moved the y over to the other side as well, because it's generally nice to write it y equals something. But I've just added 4 to both sides there. Your very last step is to replace your y with your g inverse of x. So I'm just going to write g inverse of x, and that is equal to the cubed root of x plus 4. Keep in mind that your plus 4 is outside that cubed root. It's just the x that's getting cube rooted. So those are your steps in general. You want to write y equals whatever you've got to begin with. You then literally just want to swap your x and y around, so just replace them with one another, and then you want to rearrange to get y as the subject of your equation. After you've done that, you just want to rewrite your y as g inverse, or whichever inverse you've got. And so g inverse is equal to the cubed root of x plus 4. Okay, so for question 5, we want to show that the points a, b and c are collinear. So because we've got x, y, z coordinates here, we're going to be talking about collinearity in terms of vectors, which is slightly different when you're talking about points on a line. So we're actually talking about vectors here instead. And so to prove or to show that these three things are collinear, these 3 points are collinear, we want to show that the vector AB is equal to some number times BC, and then that proves that they are parallel to one another if that's the case. And then we can also say that they share the common point B, and so that means they have to be collinear. So to prove collinearity, we need to show that these are parallel, the vectors are parallel to one another, and then we also have to say that they share a common point. So what I'm going to do is I just want to write what I'm going to show. So I want to show, so I'm just going to write WTS, I want to show that AB is equal to some number K on BC, because that shows that they are parallel. Because AB and BC share B as a common point, then if I can prove that they're parallel, I can also say they have a common point, and that means that they're collinear as well. So we first want to show this. So we're going to have to figure out what is AB. AB is B minus A, so that is going to give us 6 minus 1, 5, minus, that's not the best 5, but that's all right, minus 3, 2, and minus 1. So if we do that, we have 6 minus minus 3, that gives us 9, minus 1 minus 2 is minus 3, 5 minus minus 1 is 6. If we then look at BC, then that gives us C minus B, and so C is 12 minus 3, 9, and B is 6 minus 1, 5. So 12 minus 6 gives us 6, minus 3 minus minus 1 gives us minus 2, and then 9 minus 5 gives us 4. So from here it's not straight away obvious that we have that AB equals some number times BC, but what we can do to solve for that, because we want to kind of figure out what our K is, we want to figure out what number we're timesing BC by to get AB, what you can do is take one of the components of BC, and then, so I'm just going to pick 6, and I want to say that 6 times some K that we're solving for is equal to 9, because I want to multiply some number by BC to get AB. So that's why I'm taking my 6 here, I'm timesing it by K, and I'm saying it has to be equal to 9. And then we can solve for K. So we just want to divide both sides by 6, so we get 9 over 6, which is 3 over 2. What you want to do now is just double check that that works for all the other components. So we want to just double check, if I take minus 2 and times it by 3 over 2, do I get minus 3? Same with if you take 4 times it by 3 over 2, do you get 6? So if we do 3 over 2 times minus 2, what you can do is just find a half of minus 2, which gives you minus 1. We want 3 halves though, so we're going to take that minus 1 and times it by 3, and that does give us minus 3. Same for the 4, if we just find 1 half of 4, that gives us 2. We wanted 3 halves, so we can take that 2 and times it by 3, and that does indeed give us 6. So that just confirms that we are fine with K equaling 3 halves. We can now say that as AB is equal to 3 over 2 on BC, so A, B, C are parallel, because that's proven that they're parallel. And then you can also say, so as AB equals 3 over 2 BC, A, B, C are parallel, and then you can say as AB and BC share common point B, just because that's the point they've got in common, A, B, and C are in fact collinear. So you first have to show that they are parallel by showing that they're kind of multiples of each other. So you could also have that 2AB equals 3BC, that's fine as well. You just have to show that they're multiples of each other, so that shows that they're parallel, and then because they share that common point as well, they have to be collinear. Grand. Okay, so for part B, you want to use your answer for part A to try and say the ratio in which B divides AC. So there's a couple of different ways you can do this. One way is to kind of decide which one has to be bigger based on your ratio, and then that can help you place where B has to lie on your line AC. So you can take your AB equal to 1.5 BC to say that AB has to be bigger than BC, since AB is 1.5 times BC. So because something's 1.5 times another thing, that means it's bigger, because not only is it the same size, it's 1.5 times the size. So from that you can say that B has to be closer to C, since AB is larger, and so you can get your 3:2 ratio popping out that way, because you know that AB is the larger number of 3 and 2, so BC is the smaller number. Or what you can do is do a little bit of rearranging. so that you can divide both sides by BC to get AB over BC is equal to 3 over 2. And then from there, because you've got AB on the top and BC on the bottom, you can say that you've got this 3 to 2 ratio that way as well, kind of going top to bottom. So there's a couple of different ways to do it. You just want to make sure that you're getting your numbers the right way around. You don't want to write 2 to 3, we want to write 3 to 2. So it's up to you whether you like to think about it in terms of which one has to be larger based on this statement here. You can do a little graphic to help you, or you can get it in terms of AB over BC, see what that is equal to. Once you do that rearranging, and you should get 3 over 2 popping out. So that tells you you've got this 3 to 2 ratio. Grand. Okay, let's have a look at question 6. So question 6, we want to express 5 cos x minus 9 sin x in the form k cos x plus a, where k is greater than 0 and a is between 0 and 2 pi. And then based on that, we want to hence solve for that thing equal to 7. Grand. So there's a couple of different things to think about here. As soon as you see this sort of question, you want to be thinking about your wave function. You also just want to notice that a is between 0 and 2 pi, so we're chatting about radians here. First thing you want to do though is just get your expansion for k cos of x plus a. So I'll do that now. Okay, so we have our expansion over to the side here. You find it in your formula sheet, and that tells us that our cos of x plus a can be expanded as being cos x cos a minus sin x sin a. So rather than a and b, we've got an x and an a. And then keep in mind that when you have a plus in your bracket here, it means you've got a minus in your expansion over here, since your plus minus becomes a minus plus. So the first thing I'm going to do is just write that 5 cos x minus 9 sin x is equal to our k cos of x plus a. I'm then going to do our expansion. So k is getting multiplied by all of this, so I'll leave it as brackets for now. And we're saying that that's going to become cos x cos a minus sin x sin a. Grand. Okay, our next thing is just to make sure the k is in front of both of these. So we're going to have k cos x cos a minus k sin x sin a. Okay, what we want to do now is just look at our coefficients on the left hand side and the right hand side of our cos x and sin x, and then we can set them equal to each other. So on the left hand side, the coefficient of cos x is 5, and then over on this right hand side, the coefficient of cos x is just everything getting multiplied by cos x, which is actually k and cos a. We can do the same with our sines. So because we've got a minus here and a minus there, you can just kind of ignore the fact you've got minuses. So because you've got a 9 in front of your sin x, then we can see over here we've got a k and a sin a getting multiplied by our sin x. So that tells us that our k cos a is equal to 5, and it also tells us that our k sin a has to be equal to 9, just by comparing those two things there. Grand. Okay, so there's a couple of things we can get from this. We can solve for k, and we get that k is equal to the square root of 5 squared plus 9 squared. So if we do that, we get that k is equal to the square root of 5 squared plus 9 squared, which is equal to the square root of 25 plus 81. You can just pop all this in your calculator if you desire. And so if we do the square root of 25 plus 81, you get the square root of 106. Grand. Okay. Your next step is to figure out what tan A is. So you want to keep in mind that tan is equal to sine over cos, but we want to have our k sine A over k cos A, because then our k's cancel, because we know what k cos A and k sine A is equal to, not just cos A and sine A. So you have to keep your k's there, and that allows us just to sub in our 9 and our 5. So that is going to be equal to 9 over 5, which doesn't really simplify much nicer, but you could always, I would just leave it as it is in terms of a fraction, to be perfectly honest. Grand. Okay, your next thing is to figure out what A is, so we just have to do tan inverse of both sides. So our A is going to be equal to tan inverse of 9 over 5, and then again pop that in your calculator. So you want to do your tan inverse of 9 over 5, and that ends up giving you, keep in mind to have your calculator in terms of radians as well. So you may have to go to your settings and then you have to go into your angle unit and change it to radians. And then once you've done that, you can go back again and click enter, and that gives us just 1.06 if you round to 2 decimal places. And you can do it a little bit further by popping a 4 there as well. Then you just want to make sure that it is in fact positive in all, just with a little cast diagram. And don't forget to just have a look at whether your sine and your cos was positive. So we can see that our sine was a positive 9, so you would tick your all and your sine there. And we can also see that our cos was a positive 5, so it was also positive in cos. And so we would also tick our all and our cos. And then you want to go with the one that has most ticks. So because our A has the most ticks there, then it is just the value that we find when we do tan inverse. If that wasn't the case, then you would have to use your cast diagram as normal. So say, for example, if sine had the 2 ticks, you would have to do pi minus that value. Or if you're in degrees, 180 minus that value. So keep that in mind. Your very last step is just to write out that your 5 cos x minus 9 sine x is equal to your k cos of x plus a, just with those values subbed in. So our k is root 106. We've got our cos, and then we've got x plus our 1.064 if you want to take it to your 3 decimal places. Grand, and that is you for part A. For part B, we're wanting to solve for, or hence solve, so that implies use part A for our 5 cos x minus 9 sine x equaling 7. And again, we're using radians here. So I'm just going to get a bit more room. So because we want to use part A based on that hence, what you want to do is, rather than solving for 5 cos x minus 9 sine x equal to 7, you want to take your answer from part A. So we're actually going to solve for root 106 cos of x plus 1.064 equaling 7. Because that's a lot easier to deal with, because we've only got one trig function here. Rather than having a cos and a sine and not really knowing what to do with them, we can just say that, okay, we know from part A that that 5 cos x minus 9 sine x is actually just equal to root 106 of cos x plus 1.064, and we can solve this way. So the first thing you want to do is to divide both sides by root 106, because that just gives you cos on the left hand side. So if we do that, we get cos of x plus 1.064, and that is equal to your 7 over root 106. The next thing you want to do is take your cos inverse of both sides. So if you take cos inverse of your 7 over root 106, then that will get you 0.823. Keep in mind that we're in radians here, so you may have to, if you're not already, change your calculator to radians. And so if we take cos inverse of the left, that just leaves us with x plus 1.064, and that is equal to our 0.823. You also want to have a little think whether or not you have to find some more values. It's sometimes easier to deal with when it's in degrees, but because we also have to subtract 1.064 from this value, you may also want to find your next value up as well, because there's every chance that that answer is going to lie within your range, because we want all answers that lie between 0 and 2 pi. So what you also want to do is grab your cast diagram, and because we are dealing with cos here, and 7 over root 106 is positive, we're taking our all and we're taking our cos, and so that is also our 2 pi minus our angle here, so just a little theta. So you also want to do 2 pi minus that answer, and so if you do your 2 pi and then you subtract your answer button, then that gives you 5.46. Keep in mind that cos repeats every 2 pi, or every 360 degrees, so you can actually also add 2 pi to both of these values to make sure we're finding all of them. So not only do you want to use your cast diagram, you also want to consider whether you have to add your 2 pi to each value as well. So what I'll also do is do 2 pi plus 0.823, and that is also going to give me 7.106. and then I'm not going to have to add 2 pi to my 5.46 just because it's going to be out with my range. One way that you can figure out what your range has to be is think about the fact that cos is normally between 0 and 2 pi, but we also have to add 1.064 to that as well. So we've already said that 2 pi, let me just get it back up again, 2 pi in terms of a decimal is, I'll write this in blue. So normally, let me just write this, we want our answer between 0 and 2 pi. But we've not just got x, we've got x plus 1.064. And so we don't actually want our answer between 0 and 2 pi anymore when we're taking the cos inverse. We actually want our answer between 1.064 because we're adding 1.064 to all sides, and also 2 pi plus 1.064, which is actually 7.347. So we have to find all values up to 7.347 when we take the inverse cos to make sure that we're not ignoring any values. So because we've got up to 7.106, and if I added 2 pi to my 5.46, I'm going to be way over that, so I can stop here with those three values. Grand. Okay, so your last step is to subtract 1.064 from all your values and see what you get. So if I subtract it from 0.823, it's going to be below 0, and in our question we only want to start from 0. So by all means you can still do that and just disregard it as an answer. I'm just going to not bother writing it, to be honest. So we've then got 5.46 minus 1.064, and then in decimal form that is going to give us 4.396, and then we also have our 7.106, and we're subtracting 1.064 from that as well, and that is going to give us 6.042. So that is now all of our solutions between 0 and 2 pi for our equation that we've got there. So keep in mind that you want to use your answer in part A. You're then wanting to rearrange so you can have just cos of your bracket equal to some fraction. You want to do cos inverse. Keep in mind to use your cast diagram, and then you also want to potentially add 2 pi or 360 degrees if you're in degrees to your values as well. I would recommend, if you want to think about the fact we're normally just got x between 0 and 2 pi, but because we've got x plus 1.064, you can add 1.064 to your 2 pi and to your 0 to see what your values actually have to go between when you're at this step here. So we knew that we had to go up to 7.347, so that's why we had to consider that third value by adding 2 pi to our 0.823. And then your final answers are just once you subtract your 1.064. Keep in mind again that it's between 0 and 2 pi, so that's why we disregarded our 0.823 minus 1.064, because that was below 0, so we didn't want that as a final answer. Okay, on to question 7. We've got a little bit of integration happening here. I'll zoom in a bit, and this is for 2 marks. So we just want to use our normal integration rules, but we've kind of got reverse chain rule here. And so we want to increase the power by 1, divide by the new power, and then also divide by the differential of the bracket that we've got. So if we integrate this, we are going to first increase our power by 1, so we have a power of 8. We then want to divide by that new power, and then we also want to divide by the differential of this bracket. So 3x plus 2, when you differentiate it, you get 3. So we also have to have a 3 on the bottom. So we're going to have 8 times 3 there. So that gives us, and you also have to have your plus c, that gives us 3x plus 2 to the power of 8 over 24. And then you've got your plus c. If you wanted to as well, you could write that as 1 over 24 on your 3x plus 2 to the power of 8 plus c. Either way, you'll get full marks. So don't forget to increase the power by 1, divide by that power, and then you also have to divide by the differential of that bracket. So we have to divide by 3 as well to get that 8 times 3 on the bottom. And then that's you. Don't forget your plus c for your full marks. Okay, up next, question 8, we have a rectangular base pyramid as shown, and we've got some vectors. And what it wants us to do is express BE in terms of IJK. Okay, so we have to think about how we can travel from B to E using the vectors that we know about. And we also want to use the fact that this is a rectangular based pyramid. And that can be useful because we know that we've got some things in common here. Okay, so we want to think, how can we travel from B to E using the information given? So we know what AD is equal to, we know what DC is equal to, and we know what DE is equal to. So we want to try and use that information there. So if we start from B over here, we want to get up to E using information we know. So we don't know what AB is, but we do know what DC is. So if you wanted to, you could go back that way, keeping in mind that these two are going to be equal because they're at the same angle and they're the same length, since we've got a rectangle at the bottom. So you could do that, your AB is the same as DC, and you can go back that way. We could then go A to D and then D to E using that information. Or what you could do is use the fact that B to C is going to be the same as A to D, because again those two sides are equal. Since you've got a rectangle, they're also at the same angle, so we're good to use them. So you could do your BC being the same as AD, then we can do minus DC plus DE. So there's a few different ways to do it, completely up to yourself. So what I'm going to do is the fact that B to E is equal to, I'm going to do B to C first, so that's the same as AD plus or minus, minus DC, because we're going the wrong way down DC, so we have to do minus plus DE. So if we write it in terms of IJK, that's going to give us 6I plus 4J plus 2K. We're then going to subtract DC, which is 2I minus 4J plus 2K. And then we're going to add our DE, which is, I'll just get rid of that. It's minus 4I minus 3J plus 4K. So I've popped a bracket around our DC because we're subtracting all of it. So you don't want to get your signs the wrong way around. The biggest thing here is to notice that you can say that BC is the same as AD, or say that AB is the same as DC. So that's kind of the biggest challenge, to make sure that you're getting all the marks here, because otherwise it feels like you've not got enough information. From here though, you just want to pull together all your like terms. So we've got a 6I minus 2I minus 4I. So 6 minus 2 is 4, 4 minus 4 is 0. So we've actually not got a change in I there. And then for your J's, we've got a 4J minus minus 4J, so that's plus 4J to get 8J. Then we minus 3 to get 5J. And then for our K's, we've got 2K minus 2K, so that cancels out, plus 4K. So we have our plus 4K at the end. And then that is you. That is it in terms of IJK. Technically, if you wanted to as well, you could write 0I plus 5J plus 4K, just to be super explicit, because it says in terms of IJ and K. Okay, so on to question 9. We have a sequence satisfies the recurrence relation un plus 1 equals mun plus 4, where m is a constant. And then based on that, we want to determine the value of m after being told that the sequence approaches the limit of 10 as n tends to infinity. And then we want to evaluate u0 based on the information of u1 for part B. Grand. Okay, so we have recurrence relations, and the first thing you want to think about is that a limit exists when this value in front of your un is between -1 and 1, and it cannot equal, it has to be strictly between them. So normally we have our recurrence relation in this form, where we normally say a limit exists when a is between -1 and 1, and then b can just be any number, and it can also be a negative as well, so that's all fine. For part A though, we've been told that a limit exists, and then we just want to determine that limit. So you have to remember that the limit is given by b over 1 minus a, where b is this number here, getting added or subtracted at the end, and then a is whatever is getting multiplied by your un. So rather than having a b, we've got 4, and then rather than having an a, we've got our m. So we've got 1 minus m on the bottom there. And we've been told that that is equal to 10, because we've been told that our sequence approaches the limit of 10 as n tends to infinity. So you have to remember this formula here to begin with, and then you just want to sub in your values, and we're going to solve for m, because we now have that 4 over 1 minus m equals 10. So if we multiply both sides by 1 minus m, then we get 4 equals 10 minus 10m, just by multiplying that out. we can then subtract 10 from both sides. So we're going to have minus 6 equals minus 10m. And then we just have to divide both sides by minus 10. And so m is going to be equal to 6 over 10, which is 3/5. So for that one, there's a couple of different ways you can rearrange it. You just want to take it kind of step by step, and keep in mind that when you divide a negative number by a negative number, it ends up being positive in the same way that happens with multiplication. Grand. Okay, so we have m is equal to 3/5, and you also just want to do a little logic check. Is that an acceptable answer? And I would say it is, because we knew that m had to be some number between minus 1 and 1. It can't be greater than 1, it can't be equal to 1, and it can't be as negative as minus 1 either. So I'm happy with the fact that it's just less than 1. Okay, on to part B. We have been told that our u1 is equal to 19, and based on that we want to calculate the value of u0. So for recurrence relations, you want to keep in mind that they kind of iterate each time. So for example, I'll do this in a different colour. Because this is un plus 1, it means that your next term is always equal to m times your previous term plus 4. So in this example, we have a we want to know what u0 is, and we've been given u1. So that tells us that for part B, we can say that our u1, because that's our next term, is equal to m, which we now know is 3/5, times un. Because our n plus 1 is 1 here, then our un is going to be our u0. Keep in mind though, it is just that this is your kind of your next term up, and this is your previous term. So there's always going to be a difference of 1 there whenever you've got a un plus 1. So if this is u1, then this has to be u0 plus 4. And we can just sub in the fact that we've been told u1 equals 19. So we have that 19 equals 3/5 u0 plus 4. We can then subtract 4 from both sides, and that gives us 15 equals 3/5 u0. And then we want to, up to you how you want to think about it, you can divide both sides by 3/5, because you've got your calculator with you as well. If you find that a little bit confusing, you can just pop it into your calculator. Or you can think about it as timesing both sides by 5/3 instead, because that'll cancel out the 3/5. So because I'm just going to pretend I've not got a calculator with me for now, and I am just going to times both sides by 5/3. And that'll just give us u0 on the left hand side as desired, and then we can figure this out without a calculator, because 1/3 of 15 is 5, so 5/3 of 15 is going to be 25. So u0 has to be 25, and that is u. So on to question 10. We do have an optimization question, and it's quite a long one, but that's okay, we can still just plod through it. So we have been told that a hotel owner is designing signs showing the room numbers. We can see it here. Each sign is a rectangle with a right angled triangle above it. So you can kind of make that out from the diagram, but we do have a nicer diagram below as well. We have been told that the length and breadth of the rectangle is 5x centimetres and y centimetres. So we can see our 5x here and our y here. The shorter sides of the triangle are 3x and 4x centimetres. We've then been told that the area of the sign is 150 square centimetres. Based on that, we want to show that the perimeter P centimetres of the sign is given by P equals 9.6x plus 60 over x. So whenever it comes to these optimization questions, you generally always have a show that in part A, and you have to use all the information given to try and show that. And then your part B is basically just a glorified stationary points question, because we just want to find the minimum value of P. So we're going to want to differentiate, set it equal to 0, solve for x, and then do a nature table to make sure it's a minimum. But so generally speaking, if you don't like optimization questions, I would recommend doing part B first, and that should be achievable if you're fine with doing your stationary points. And then think of part A as being like a little bonus. If you can get those 3 marks from part A, then even better. But we do have all the information required to try and figure it all out. The issue that we currently have is that we've got a y included. And so if we try and figure out what our perimeter is, we're going to say it's 5x plus y plus 4x plus 3x plus y. So we've got these 2 y's here that we don't want in our final equation. So we have to do a little bit more extra work to get that in the first place. But you're always given some useful information, and that useful information is that the area of the sign is 150 square centimetres. So we're going to use that information to try and rewrite y in terms of x. Grand. Okay, so let's start with this. So we want to think about the area of the sign and what that is in terms of x's and y's. So the area of a rectangle is just going to be length times breadth. So I'm just going to do this up here. So area of our rectangular part is going to be 5xy, because we're just doing 5x times y. And then the area of our triangle is going to be a half base times height. We have to think about our base and our height. We have been told that this is a right angled triangle. So we know that we have this right angle here. And so you kind of want to think about it in terms of, if you were to kind of draw it on its side, then you have this 90 degrees here, and then you have this slanty side. So we know that this is definitely the height when this is the base, just because of that 90 degrees. So if that is 3x and this is 4x, then when we do a half base times height, we're going to have a half on 4x on 3x, or the other way around, doesn't really matter. A half times 4x is going to be 2x, and then 2x times 3x is going to be 6x squared. So we now know that the area of our shape is equal to 5xy from our rectangle plus our 6x squared from our triangle as well. So that's our total area. We then want to set that equal to 150, because we know that our area of this total sign is equal to 150 square centimetres. And now we can try and use that information to rewrite y in terms of x. So we want to write this in terms of y equals something to do with numbers and x's. So I'm just going to get rid of, I'll just rewrite it down here. So we have got that 5xy plus 6x squared is equal to 150. And so what I'm going to do is just subtract 6x squared, so that we have 5xy equals 150. Oh, not divided, just minus your 6x squared. And then I want to divide both sides by 5x, just to get y on its own. And so if you want, you can pop it, I'll pull it through separately actually. So technically we've got 150 minus 6x squared all over 5x. And then we can rewrite that a little bit nicer, because 150 divided by 5x is just going to give us 30 over x. Since 150 divided by 5 is 30, and then we've still got that division of x. And then we have minus 6x squared over 5x. So we're still going to have a 6 over 5. There's not much we can do with that. And then we have an x squared divided by an x. So that just leaves us with an x up here on the top. So all I've done there is I've taken that division into both terms separately. So I'll write it like this. So I've divided that by 5x and I've divided that by 5x, and then I've just simplified. The reason I've done that is because you'll see in your final answer, we do kind of have these separately. They're not under the one in the one fraction, and we do have something over x. So it makes sense to just pull them into each term separately. But we now know that y can just be rewritten as 30 over x minus 6 over 5x. So that's the kind of the first part of the question. You want to use this additional information, in this case it was about the area, to say what y is in terms of your x's. And now we can try and think about the perimeter, because we've already said that our perimeter, which is just all the outside lengths added together, is going to be equal to 5x plus 2y, because we have our y here and our y here, plus 4x plus 3x. And if I just pull that together a little bit more, we've got 5x plus 4x plus 3x, so that is going to give us 5 plus 4 is 9, 4 plus 3 is, 9 plus 3 is 12, so we have 12x, and then plus 2y. However, we have said that y is actually equal to 30 over x minus 6/5 on x. So I'm just going to rewrite that. So I've still got my 12x at the start, and now I've got 2 times our 30 over x minus 6 over 5x. And I can make this a little bit nicer. Hopefully I have enough room. I'll write it over here to begin with, and I'll come back down. So we've got 12x, and then I'm multiplying both of these things by 2. So we're going to have 60 over x popping out there, because 2 times 30 is 60. And then over here we're going to have 2 times your 6, which is going to give us a 12 on the top. Keep in mind that a whole 2 is the same as 2 over 1. So if you're multiplying these fractions, that's why I'm just multiplying the numerator by the 2. Because technically in the denominator we just have a 1, which isn't going to change anything. So if that's useful to think about it that way, then by all means. Otherwise, just remember to multiply a whole number by just the numerator of the fraction. So we've also got our minus 12 over 5x over here. Grand, okay, we are almost there. So we have our 60 over x, that's all good. And we also have our 12x minus 12 over 5x. So if you want to pop that in your calculator to do the 12 minus 12 over 5, then by all means you can do that. Because this is in decimal form, I would probably recommend just doing that. Otherwise you're going to get a fraction if you do it by yourself in your head. Grand. So if you do 12 minus 12 fifths, you do end up getting 9.6. So if we pull those x's together, we get 9.6x. And then we've still got our 60 over x there as well. So all I've done is I collected the like terms of our x's together, and then that 60 over x is still popping out. And that is your final answer. So keep in mind that you're using the additional piece of information. So in this case, it was about the area to write y in terms of your x's. And then you just want to think about what your perimeter is. And then when you get to the point where you can sub in for y, just sub in what you've shown up here, and then do a little bit of rearranging until you get the final answer. Grand. Okay. For part B, we have been told that each sign will be lit using a lighting strip placed around its placed around its perimeter, and the hotel owner requires the perimeter of the sign to be as small as possible. Doesn't want to spend too much money on it, so we want it to be as small as possible. So based on that, we want to find the minimum value of P. So you don't have to have done part A to get part B, because it was a show that question, so we know what the perimeter is anyway. So we can just use that information there. We have that P equals 9.6x plus 60 over x. And because we're wanting to find the minimum value, then we're going to have to differentiate, set it equal to 0, and solve for x, because it is just stationary points. So we can say that stationary points occur for dp of dx equal to 0. Normally you have a dy by dx, but we don't have a y equals, we have a p equals. So that's why I'm going to say dp by dx. Rather than stationary points as well, you could say max slash min occurs for the derivative equal to 0. Whatever works for you. I would generally recommend doing a little statement like that at the start though, just to kind of prompt yourself, and then also just to show the examiner that you know why you're doing what you're doing. So our next step is to just differentiate. So I'll rewrite our p here. So we have p equals 9.6x plus 60 over x. And then we want to differentiate that. So that tells us that we don't want a division of x up here, because we can't deal with that yet in terms of differentiating. We have to move it up so that we have x to the power of something. So you want to keep in mind that when you have an x term on the bottom, to move it up to the top of your fraction, you can just write it as it normally is, and you just have to change the sign of the power. So technically that's x to the power of 1, so when we pull that up, it's x to the minus 1. So keep that in mind. If we had an x squared on the bottom, we would pull it up and it would be x to the minus 2. But because we just have x to the 1 there, then that's all we've got. So we can now do dp by dx, so we're just differentiating. So 9.6x just becomes 9.6. And then we're going to times by our power, so we're going to have minus 60. Our x stays the same, and we decrease the power by 1, so we're going to have a minus 2. Grand. Because we're solving for x, I'm going to rewrite that as 9.6 minus 60 over x squared, just so we can actually do some solving. And we are setting that equal to 0 to find our ideally minimum value of p. So now we have to just rearrange this so that we can say x equals. So if we do a little bit of rearranging, I'm going to move the 60 over x squared to the other side, and I'm just going to write it the other way around as well, so that we've got 60 over x squared equals 9.6. And then we want to multiply both sides by x squared, so we're going to have 60 equals 9.6 x squared. I then want to divide both sides by 9.6 to get x squared on its own. So that gives me x squared equals 60 divided by 9.6. So if you do 60 divided by 9.6, that ends up getting us 6.25. And then we want to do the square root to get rid of that x squared. So the square root of your answer, which I would just do in your calculator, is equal to 2.5. So it's going to be plus or minus 2.5. Because keep in mind, when you do the square root, you have to keep in mind that that positive number times itself will give you 6.25, but minus 2.5 times minus 2.5 will also get you 6.25, because a negative times a negative is still a positive. Okay, so now that we have our values of x, we have to just determine which one is a minimum, because we want to know the minimum value of p, and we're not sure whether this 2.5 and minus 2.5 is potentially a maximum value or a point of inflection. So we have to do our little nature table. So I'll do the nature table over here. I'm just going to do it in blue so it's obviously a different part. But you have to do all of this to get your full marks. So we're going to have our value of x. We're going to have our dp by dx. And then we're also going to have just our general shape, or slope you can write as well. Doesn't matter. Grand. And then keep in mind that you're wanting to pop in your values of x that you've solved for. And then we also want to think about values of x on either side of that as well. So if I have I'll do minus 2.5 here. I then need a number between minus 2.5 and 2.5. And then I need a number on either side of these as well to determine their general shape. So for ease, let me have a look at our dp by dx. So this is an example where, so more often than not, I would pick x to be 0, just because it's generally nice when x's can just cancel out. But because we have a division of 0 with our dp by dx, we can't pick 0 as an option there, because 60 divided by 0 isn't defined. So for that reason, I'm just going to pick the number 1, because that's a little bit easier. And then for here, you can really pick anything you want. I'll just do minus 5, and I'll do 5. You can pick any numbers, it's really up to yourself. So we know at minus 2.5 and 2.5, our derivative is 0, because they're the stationary points. And then we just have to assess what our dp by dx is equal to when x equals minus 5, 1, and 5, and we can see whether that's positive or negative. Grand. Okay, so if you want, you can just think about your dp by dx being equal to this bit here. That's probably the easiest, because I've just rewritten it slightly so we can sub in easily. So try not to get confused with your working. You want to find your dp by dx and sub into that, and you want to ideally have it in its simplest form rather than having x to the minus 2. Again though, because this is a calculator paper, you technically could just sub in with your x to the minus 2 and just use your negative powers on your calculator, but it's good practice to move that x to the minus 2 back down to x squared. Grand. Okay, so when I sub in x equals minus 5, we're going to have a minus 5 all squared on the bottom, which is going to give us a 25, a positive 25. So what we actually have there is 9.6 minus 60 over 25. And that gives us a positive number. If you pop that into your calculator, it gets you 7.2. So we have a positive, so I'm just going to pop a positive sign. When we pop a 1 in there, we're going to get 9.6 minus 60 over 1, which is just 60. So 9.6 minus 60, definitely going to be negative. So I'm going to pop that as a negative. And then when I sub in 5, I'm actually going to get the same as what I done when I had minus 5, because I'm doing the values squared. And since minus 5 squared and 5 squared is just 25, then you're actually going to get the same over here. Still going to be positive, because you're still going to have 9.6 minus 60 over 25. So that tells us that we have got a positive, then a stationary point, then a negative, then a stationary point, and then a positive again. So that helps us determine which value of x is our minimum value. And you'll notice we have our minimum value when x equals 2.5. So that tells us that that is where our minimum occurs. So at the very end, you want to say that your minimum value of p occurs when x equals 2.5. Nice, okay. Technically as well, you could have disregarded your negative 2.5, because we're talking about perimeter here and the length of something. I'll scroll back up. It doesn't make sense for x to be a negative number. And so if x was a negative number, then you would have that the length of your triangle is 5 times minus 2.5. And so it's going to be a negative number there. Same with the lengths for 4x and 3x. You're going to get negative numbers, and that doesn't make sense when we're talking about the length of something. You would never say, like, the length of a plank of wood is minus 5 centimetres. It doesn't make sense. It would just be 5 centimetres. So if you wanted to make your life a little bit easier, you could have disregarded the negative 2.5, but you still would have done the nature table in the same way. You would have just had to do this part instead, because you wouldn't have to consider the minus 2.5 and then something on the other side of it. So you would still confirm that it was a negative. But if you forget to disregard the minus 2.5, then that's okay. You can just do a slightly bigger table and then say that your minimum value still occurs, x equals 2.5. If you notice that though, then by all means say that x has to equal 2.5, just again to show the examiner that you understand what's happening here. And then that is you. So it's a solid 6 marks for working through it all. It does take a little bit of time, but to be perfectly honest, if you're feeling okay about stationary points questions, then it is a nice 6 marker to get. Okay, so for question 11, we want to solve 3 sine 2x plus 4 cos x equals 0 for x between 0 and 360. And I've also grabbed our trigonometric formula from your formula sheet. Straight away with this question, you want to notice that we have a 2x here. So that tells you that we're going to have to use our double angle formula. So keep a little eye out whenever you have something like 2x and it's asking you to solve, then you want to pop that in. Right, grand. So let me just rub that out. Grand. Okay, so because we have sine of 2x, it tells us that we're using this bit here. The nice thing about sine 2a is that we only have one option. You'll notice for cos 2a, you've got a couple of different options, so there's a little bit more thinking involved. But we can just go straight ahead and rewrite our sine 2x as 2 sine x cos x, just using that formula there. Keep in mind though, you've got this 3 getting multiplied by the whole thing. So this is the same as 3 times 2 sine x cos x. And we've still got our plus 4 cos x equals 0. And then what this gives you is 6 sine x cos x, because it's all getting multiplied together. We've got a 2 times a sine x times a cos x, and that's also getting times by 3, so you can just pull those numbers together. Okay, at this point you may think, not really sure what to do here. I've still got sines and causes, and now I've got like a sine getting multiplied by a cos, so I don't really know what's best here. Generally speaking, whenever you're trying to solve for something, you want to be thinking about whether you can factorize in terms of like a trinomial. So if we had like a sine or cos squared, then you want to maybe think about considering it as a trinomial and trying to pop it into 2 brackets. You want to consider if you've got a difference of 2 squares, or you want to think about your taking out a common factor. And so you'll notice that we can take out a common factor of 2, because 2 goes into 6 and 2 goes into 4. And then both of these terms also have a cos x in them. So I can actually take 2 cos x out as a common factor. And when I do that, it leaves me with a 3 sine x here, just because 2 cos x times 3 sine x will give me my 6 sine x cos x. And then over here, I'm just going to get left with a 2, because 2 cos x times 2 is going to give me my 4 cos x. Grand. So for this one, we want to just kind of solve this as we normally would if we had just numbers and x's. So we're just going to set both of these things equal to 0 separately and then solve. So we've got 2 cos x equals 0, and we've got 3 sine x plus 2 equals 0. So that just gives us cos x equals 0, and this will give us that sine x equals minus 2 over 3 if we move that 2 over and then divide by 3. Grand. Okay, at this point we want to think about when does x equal 0, and you want to make sure that we're getting all the values as well. So we also want to maybe do a little cast diagram, because we want all the values of x that lie between 0 and 360. So if you have a little look at your cos graph, there you go, we have that cos x equals 0 at this point here and at this point here. That is where we're at 0 on our y-axis. So that's the 2 points, and we want to think what values of x does that give us. So you want to remember that we start here at 0. This is going to be 180. This over here is 360. And so this is going to give us a 90 degrees and a 270 degrees at that point. So x has to equal 90 and 270. If you were to do this on your calculator, you would have done cos inverse of 0. And that would only give you one value. It would only give you your 90. So you would have to use your cast diagram and think, okay, we're positive in all and cos. And so you would also have to do 360 minus your value. So you do 360 minus 90 to get your 270. So keep that in mind. If you're going to use your calculator, rather than think about your cos graph, then you have to use the cast diagram as well. Grand. Okay, let's also look at our sin x. So what to do? What I would normally do is do sine inverse of just 2/3, and then we'll use the cast diagram to tick where we're positive. So sine inverse of 2/3, you can pop that on your calculator, and that ends up giving you 41.81 if we round to 2 decimal places. but that's not the x we're looking for, so I'm just actually going to call that theta for now. We had sin x equals negative 2/3. So because it's a negative, it means that we're negative in sin and all. So we're going to have to tick our tan and cos. So whenever you're negative, you want to tick tan and cos. So that tells us that our x is going to be equal to 180 plus our 41.81, just from the tan bit. And then from the cos bit, it's going to be 360 minus our 41.81. So if you do that on your calculator, you can do 180 plus your answer, and that gives you 221.81. And then for this one, if you do 360 minus 41.81, that gives you 318.19. So don't forget to use your CAS diagram. Also keep in mind that if you're going to do your, for this one, if you want to do sine inverse of your minus 2/3, then you still have to get the second value, and you're going to have to do that from your CAS diagram anyway. And so that's why I would recommend taking sine inverse of the positive fraction and then tick the ones that are positive instead of negative. So that's why we ticked T and C, because we were negative in sine and all, since we had a negative number here. Because if you pop that on your calculator with your minus 2/3, you would get minus 41.8, and then you would have had to also do your 180 minus your minus 41.81 to get your second value, and that would give you your 221.81. But then you would also have to add 360 onto your 41.81. Because we want all the values between 0 and 360, and that was giving you a negative number, so that's outside that range. But you can use the knowledge that your sine and cos function repeat every 360 degrees, and so you can actually just keep adding 360 or taking 360 away from your values until you get all the values inside the range. So that would have got you your 318.19 if you'd done your minus 41.81 plus 360. But generally speaking, I would do it the way that I've done it here. You want to take the inverse of the positive fraction and then just tick your CAS diagram appropriately, and that's a little bit easier to think about. Okay, so for question 12, we have two functions defined on the set of real numbers. So we've got f of x equals x to the power of 5 plus 3, and g of x is equal to 1 minus x cubed. And we want to find an expression for h of x, where h of x is f of g of x. So we have some composite functions here, and you want to remember that if we're doing our f of g of x, it means that you're taking your g of x and you're subbing it in to your f of x. So I sometimes like to rewrite that as f of 1 minus x cubed. So I'm just replacing my g of x with what g of x actually is, and that tells me that I'm subbing 1 minus x cubed into my f of x function. So wherever I see an x in my f of x function, I'm now replacing it with 1 minus x cubed. So you end up getting 1 minus x cubed all to the power of 5, and I'll keep it in brackets, plus 3. So it's a little bit of a gross one, to be honest. So yeah, generally speaking, I would write it out like this to kind of prompt you correctly, because keep in mind that if you have like f of 2, for example, it means that you're just replacing your x with a 2. So you're doing the same thing here, but rather than it being an exact number, it's a little bit of an expression instead. So you just want to sub that full bracket into your x, and so we have this popping out. So that's all you can do for part A. Find an expression for h of x where your h of x is f of g of x. For part B, we want to find h prime of x. So we're going to want to differentiate here. So we're going to have a little bit of chain rule involved, because we can see we've got this bracket which has an expression in it to do with x, and that's all to the power of 5. So h prime of x is going to be, you still use your normal rules. We're going to times by the power, keep our bracket the same, and then decrease the power by 1. And then we also have to multiply by the differential of this bracket. So what happens when you differentiate this bracket? The 1 disappears, and then your minus x cubed is going to become minus 3x squared. So we're also timesing by minus 3x squared. So keep in mind you're multiplying by the power, then decreasing the power by 1. And then that 3 is going to disappear at the end. So you just get left with this here. We can make that a little bit nicer. We can pull together the minus 3 and the 5 to get minus 15. We're then going to have our x squared potentially at the front, and then you can write your bracket as well. You could technically write this up with the x squared at the end, but generally speaking it's probably better notation to write it this way, so that you've got the numbers, the x term on its own, and then the bracket at the end. And that is for your 2 marks. So keep in mind how to do composite functions, and then don't forget about chain rule when differentiating. So you also have to multiply by the differential of the bracket, and then that is you. So for question 13, a radioactive substance which has been collected decays over time, and the mass of the radioactive substance remaining in the model is modelled by m equals 150 e to the minus 0.0054 t, where m is the mass in micrograms, t years after the radioactive substance was collected. So our time is in years here, and our m is our mass. So based on that, we want to determine the initial mass of the radioactive substance. So whenever I ask you to do something to do with the initial, you want to think about t being 0, because no time has passed. If we're thinking about what is it started with, then we're at 0 years here, because it's when you're doing it to begin with. So all you want to do is take your equation, and you want to set t equal to 0. So we're going to have 150 e to the minus 0.0054 times 0. Anything to the power of 0 is just 0. It is just 1, sorry. So this is going to be 150 e to the 0, which is just 150, since e to the 0 is just 1. So that tells you that the initial mass of the radioactive substance is 150 micrograms. So by all means, if you want to write micrograms as well, then you can. Okay, up next, part B. We want to calculate the time taken for the mass of the radioactive substance to decay to 120 micrograms. So we're wanting to calculate the time taken. That tells us we're going to try and solve for t, and we've been told something about the mass. We've been told that the mass is now 120 micrograms. So I'm going to set the m equal to 120, because that's what that sentence has told us, and we're looking for t. So we have that 120 is equal to 150 e to the minus 0.0054 t. So because t is kind of stuck inside this exponential, we have to do a little bit of work first. So I first want to make sure I've just got my exponential on its own. So it's currently getting multiplied by 150, so I'm just going to divide both sides by 150. So that ends up giving me 120 over 150, and that is equal to my exponential to the minus 0.0054 t. And we can make that a little bit nicer as well. 120 over 150, you can cancel the zeros out, and then 12 divided by 15, you can divide the top and the bottom by 3 to get 4/5. So we have that 4/5 is equal to this exponential. Because this exponential is now on its own, we want to make use of the fact that the natural log of an exponential is equal to 1, because they cancel out since they're inverses of each other. And then we also know that when we take the logarithm of something, we can fly our powers. So we're going to take logs of both sides. So we're going to have ln of 4 over 5 is equal to ln of your e to the power. We're then going to fly that power down, because we're talking about logs now, and we know that we can fly our powers. So we're going to have the ln of 4/5 is equal to minus 0.0054 t, and that is now just getting multiplied by our ln e. We've said though that ln e is just equal to 1, and so that actually cancels out quite nicely. I'm just going to get rid of it for now, because timesing something by 1 is a little bit redundant. It's now at this point that we can get t on its own just by dividing both sides by minus 0.0054. So we're going to have ln of 4/5 getting divided by minus 0.0054, and that is going to give us t. And then if you pop that into your calculator, don't forget your brackets on the top. So to get the natural log as well, you want to do shift and then your log button. Then you can do your 4/5. And then you want to divide that by minus 0.0054. And that gives you 41.32 if we take it to 2 decimal places. I don't think the question asked for a specific rounding, so I would probably just take it to 2 decimal places there. And that's in terms of years as well. So it's going to take 41.32 years for it to decay down to 120 micrograms. So it takes a lot of time. And that is you. So for that sort of question, you want to keep in mind that it's similar to a half-life question, but rather than being told that the mass is halving, you've been told that we want to get it to 120 micrograms instead. So rather than having a half over here, we ended up with 4/5. But you still want to just rearrange in that normal way. You then want to take the logarithm of both sides, the natural log. You want to fly that power down, cancel your ln, and then divide by your coefficient of t to get t on its own. And that is u. Okay, last but not least, we have question 14, which is quite a big circles question, to be honest. However, the first part, A and B, is just your standard state the centre and radius when given your equation of the circle. So circle 1 has the equation x plus 5 all squared plus y minus 6 all squared equals 9. And what you want to do is compare that to the equation given in your formula sheet. So you get told that whenever it's in this form, that your centre is AB and your radius is r, which is the square root of r squared. So to state the centre and radius, we just have to take the numbers that are inside the bracket with your x's and your y's, and you just want to change the sign. So the centre is going to be minus 5, 6, because we're changing the sign. And then our radius r is going to be the square root of 9, because this bit here is technically r squared from your formula. So to get r, we just want the square root, and that gives us 3. So we know that our circle 1 over here has centre minus 5, 6, and radius of 3. Grand. Okay, for circle 2, we have the equation x squared plus y squared minus 14x plus 6y plus 54 equals 0. And again, we want to state the centre and the radius. Generally speaking, there's a little bit more work to do with these ones for the radius, but you still just want to have a little look at your formula sheet and then compare from there. So for our centre, what you want to do is half the coefficients of your x and y, and you also want to change the sign as well. So if we half our coefficients, minus 14 goes to minus 7, and then we change the sign, so it becomes 7. Same with the 6 here, we're going to half it to get 3, change the sign to get minus 3. Grand, so that's the centre. And then our radius is given by the square root of g squared plus f squared minus c. And so that is going to give us the square root of, technically, minus 7 squared plus 3 squared minus 54. And I'll continue down here, so that gives us root 4, which is 2. So we've now been told that circles C1 and C2 and C3 are touching as shown in the diagram. The centre of C3 lies on the line joining the centres of C1 and C2, and based on all of that, we want to determine the equation of C3. So I'm just going to pull some information down from there. So for C1, we have that the centre is minus 5, 6, and the radius is 3. And then for C2, we have the centre is 7 minus 3, and the radius was equal to 2. And so we're wanting to use that information and the diagram given to try and determine the equation of C3. So to determine the equation of C3, we need to know its radius, and we also need to know its centre point. Based on the way that our circles are touching, we can see that this line joining our two centres here is joining the two centres that we know about. So we know our centre C1 is minus 5, 6, and we know that our centre C2 is 7 minus 3. And so that means we can figure out the distance of this full line by just doing the distance formula with those 2 points. So we can start there. This is just for part C, obviously, but we'll start there by doing our distance formula, and our distance formula gives us the square root of the difference in your x's all squared plus the difference in your y's all squared. So if we do the difference in our x's, it's going to be 7 minus 5. And then in our y's, it's going to be minus 3 minus 6 all squared. And so that gives us the square root of, so 7 plus 5 is going to give us 12, so we're going to have 12 squared. And then minus 3 minus 6 is minus 9, so we're going to also have minus 9 squared. So that gives us the square root of 144 plus 81. And then you can pop that into your calculator at any point, to be honest, to make your life a little bit easier. But that gives us the square root of 225. And if you do the square root of 225, you end up getting 15 popping out. And so that is useful because we know that this full distance between those two center points here and here is 15. And we can use the other information about our radii to help kind of figure out what has to be our full distance from one side of the circle to the other, or just, to be honest, from the centre out the way. So you can think about it as either ways. We know that this full distance is 15, and so we can keep in mind the fact that our radius for C2 is 2, and our radius for C1 is 3. So if this full distance is 15, then to just get from here to here, it's going to be 15 minus 2, because we just don't want this little bit of the radius there, because that's not part of our C3's radius. So we can do 15 minus 2 to get that distance, and that gives us a distance of 13 from here all the way down to here. So that gives us 13. And then we also want to think about the fact that this is just touching internally here, and so our distance from here to here is just going to be our radius of C1, which is 3. And so if we want this full distance from this here all the way up to here to get our full diameter, it's going to be 13 plus 3, and 13 plus 3 is going to give us 16. So this tells us that diameter of C3 is 16, just using kind of information about the full distance between centres and then the little bits about our radius. Then that tells us our diameter is 16, and so the radius for C3 has to just be half of that. So our radius is going to be 8. Nice. We can also try and determine our centre point as well, because we need two things for the equation of a circle. We need our radius, and we also need our centre as well. What we can do is think about the fact that, again, our full thing is 16 from here to here. And so if we just want to consider the line that we know about, and we can use some ratios, then it tells us that from this centre point out to here, that's going to be 8 minus 3, because we know that here to over here has to be 8, since that's our radius, but then we're just missing this little bit of our C1 radius. So we're going to have 8 minus 3, and that will give us 5 for this length over here. And then for over here, we're still going to have our radius from this point here over to here. That gives us our radius, sorry. So that's going to be 8, and then we just have to add our other 2 for that radius to get over to here. So this distance is going to be 10. So that can help us in terms of a ratio for talking about what we've got here. So if we now have just this line that we were given to begin with, we have this 5 to 10 ratio in which C3 is dividing the line from C1 to C2. So I'm just going to draw this down here so that we've got it. So we've now got this straight line which is joining our C1 and our C2, and then our C3 goes up here actually, apologies. And we now have this 5 to 10 ratio, which we can simplify by dividing both sides by 5, because ratios can just simplify as much as possible, and that gives us a 1 to 2 ratio. So we can now use this with a little bit of vector knowledge to figure out what C3 has to be, because we now know that C1 to C3 is equal to 1, and C3 to C2 is equal to 2. And so we can write it in terms, that equal sign shouldn't be there, so we can write it in terms of this fraction here, just using our knowledge of how C3 is splitting up the line C1 to C2 with that ratio. And so we can kind of cross multiply and say that 2C1 C3 is equal to C3 C2. From there, we can sub some stuff in, and we know that C1 to C3 is the same as C3 minus C1. And then the same over here, C3 to C2 is the same as C2 minus C3. So this is just using some vector knowledge with the fact that A to B is actually just B minus A. So I'm doing that here just with C1, C2s and C3s instead. We want to solve for C3, so I'm just going to multiply that out to get 2C3 minus 2C1 is equal to C2 minus C3. And I want all C3s on my left hand side and everything else on the right hand side, since we're trying to solve for our C3 centre. So I'm going to add C3 to both sides to get 3C3, And I'm also going to add 2C1 to both sides to get that over as well. So I'm going to have 2C1 on that side now. Grand. Let's sub in some of the information we know. So we know that our centre of C2 is 7 minus 3. So I'm going to write that in vector form now. And we know that our C1 is minus 5, 6. Grand. We have 2 times this vector, so I'm going to do that here. 2 times minus 5 is minus 10. 2 times 6 is 12. So we've got 7 plus minus 10, so that's just 7 minus 10, which gives me minus 3. And then minus 3 plus 12 is the same as 12 minus 3, so I get 9 there. And that is what is 3C3 is equal to. So we can just divide each component here by 3 to get C3 on its own, and that gives us minus 1, 3. So that tells us that our centre of C3 is just the point minus 1, 3, using that knowledge of the total distance with the ratio that we figured out there, alongside some vector kind of manipulation there to figure out what C3 has to be with a bit of rearranging. So our very last step is to write our equation of the circle. And generally speaking, you want to write it in the form x minus al squared plus y minus bl squared equals r squared, just because that's the easiest one. So because our centre is minus 1, 3, we're going to have x plus 1 all squared plus y minus 3. So don't forget to change the signs. And that is equal to our r squared. Our radius was 8, and so that's going to be equal to 64. And that is your final answer. To be perfectly honest, it is a hard question. I generally find that the problem solving circle questions can be the trickiest. Generally speaking though, you want to just think about all the information given in the question and see if there's anything you can do with it, and just try to apply as much knowledge as you know. Generally you want to think about, can you split your line up into some ratios, and then can you also use like the distance formula, and that will normally get you quite far, to be perfectly honest. A little alternative method for finding C3 is to use your ratio in a slightly different way, and you can kind of just do it by inspection instead. So I'll just scroll back up to here. So we know the distance between C1 and C2, and we know C1's centre and C2's centre. So I'm just going to add this over here. And we've at this point said that we've already got a 1 to 2 ratio. So you can think about this in terms of the change in x and the change in y, and that can help you determine what C3 has to be. So what I'm going to do first is think about what is your change in x. So we went from minus 5 up to 7. So minus 5 up to 0 is 5, 0 to 7 is 7. So that's a total change of 12. So our little change in x here is 12. And our change in y, we went from 6 to minus 3. So 6 down to 0 is 6, 0 to minus 3 is 3, so that's a total difference of 9. So what we can then do here is think about the fact that we've got this 1 to 2 ratio. So we've got 3 parts in total, just 1 plus 2 is 3, and we know that going from C1 to C3 is just one of those parts. So what we can do is just think, okay, we don't want our full change in x and y, we just want a third of our change in x and y to go from C1 to C3, because it's just 1/3 of the total distance. So that tells us that from C1 to C3, we want our change in x to be 1/3 of 12, which is going to be 4, and our change in y to be 1/3 of 9, which is going to be 3. And so what we can do from there is use that information to say, okay, we're going from minus 5 up to 7, but we only want to do a change in 4 this time. So minus 5 plus 4 is going to give you a minus 1. And then we're going from 6 to minus 3, so we're kind of going down the way instead of up the way. And we're doing this change in 3 this time. So we can do 6 minus 3, and that is going to give us 3. So that's an alternative way to get that minus 1, 3 popping out, is just kind of by inspection. So it's really just preference. Either way, you'll still do everything else the same, and you'll sub in the same at the end as well.